Question A is very straightforward. They just give you 20 data and then you have to write down the median and the mode. And these data are already in ascending order, so you don't need to rewrite it. Since we have 20 data, so if we just separate to two parts, we have 10 and 10. The median is talking about the 10 one and the 11 one. Because the total number is even number, we don't find the exact middle data. That's why we just use the most middle data and then we get the average. So the median is equal to 31 plus 31 divided by 2. That means 31. No unit for ages. And then we have to find the mode. The most common result, we find that 23 the frequency is 3 times. It appears 3 times, while all other values just appear once or twice. So our mode is only 23. We finish part A, then we proceed to part B1. They give you a stem and leaf diagram, so you know that this is 20 plus A, and then this data representing 25, 26, 27, like this. They try to give you the range. So minimum is equal to 20 plus A, while maximum is equal to 60 plus B, is how you express it in terms of equation. And then given range is equal to 47, which means the maximum minus minimum is equal to 47. So we just plug in the data, 60 plus B and then minus 20 plus A. Don't forget the bracket here because we are going to minus the whole thing. So it's 60 plus B minus 20 minus A. Tidy up, we find that B minus A is equal to 7, which means B is larger than A by 7. Then you may write down all the possibility, and based on the limitation of B, then you may cross out some of the possibility. So A and B combination. If A is 0, A can be 0 to 1, 2, 3, 4, 5. It can't exist 5 is because it's arranged as left hand side of 5. So if it is 6, then A will replace right hand side of 5. That's why maximum of A is 5. And then similar reason, then we can write down the corresponding combination, corresponding value of B, because B is equal to A plus 7. So this one will be 7, 8, 9, 10, 11, 12. So in stem and leaf diagram, it's impossible to have 10 here. That's why we cross out this. And then now we have three solutions, 3 combinations, and then we have to check, do we need to exclude any other thing? They didn't say A must be positive or something else. There are no other limitations. So we make our conclusion is there are 3 solutions. So after that we can just continue. Therefore, the first situation, case 1, A equal to 0, at the same time B equal to 7. If not, then we have case 2. If A is equal to 1, then B should equal to 8. If not, we have case 3. If A is equal to 2, then B equal to 9. Remember, one box representing one solution. That's why it's a must for you to write down this symbol. This symbol means N. So that's the logic in solving B1. Come to the last part of part B. I can simply tell you that this one is really troublesome, and I have no idea why they need to create such kind of trouble questions. The biggest problem is we have 3 different cases in part A, and all are feasible. So logically, we should try The first case, okay, we have one result. The second case, we have one result. The third case, we have one result. Even though the fact is no matter which case, they will give exactly the same result there. But this will make the candidates really confusing. But anyway, I just assume this is the first result first. That means A is 0 and B is 7. After that, to do this, we are going to choose the combination of A and B and see how many combination their differences exist 40. The best method, it seems like you imagine that you choose from committee B first. It's because there is a less number compared with committee A. It's easier. So we find the stage 1 B. For example, like if B is 20, there is a limitation for us in committee A. A need to be larger or equal to 61 so that their differences exist 40. That means at least 41. So I'm searching, is there any 61 to 69? I find 3 numbers. So that means if I choose 20 from committee B, then I have 3 choice to get this to fulfill the requirement. So I write down the number is 3 choice here. And then if this is 25, you do the same. At least it should be larger or equal to 66. We also have 3 choice. If it is 26, 27. So 3 and then 3 here. After that, we consider 33. If B is 33, add 41, then it will become 74. But we don't have such kind of large number in committee A, so this one we will just negate it until we find a really large number from committee B. So just now we from the smallest value, we consider from the greatest value now. If it is 67, then part A should be smaller or equal to 26, such that the differences is still exist 40. So 26, we have this amount, 23 to 17, so I have 9 choice. Similarly, 67 again, so just exactly the same, 9. How about if it is 59, then it should be less than 18. 18 less than or equal to 18, I have 2 choice. And then 52, then this one should be 11 or below. We don't have any choice, so we can stop here. So all the middle situation in committee B, we can just simply ignore it. It do not produce any combination to have differences greater than 40. So now we have this amount of choice we can choose. So therefore the probability is equal to 3 choice plus 3 plus 3 plus 3, and then for another side we have 2 plus 9 plus 9. And then how many combination? In committee B we have 13 choice, and then for each choice in committee B we have 20 choice in committee A. So that's our answer, 8 over 65. Logically, if you need to prove that this is correct, you have to consider if A is equal to 1 and B equal to 8, and then you have the similar calculation again. You will find that it's because 0 to 2 is quite close, and also 7 to 9 is quite close. It do not affect the number of choice here. But if you really need 100% accurate, that you have to do so. So that's why I say that I don't understand why why HKEAA make this become that kind of troublesome questions. I don't think it is a very good questions.